Hello everyone, I'm Surender, SOC Analysis from BCBUZZ Technologies. This is my LinkedIn profile and job profile. Today we are going to learn about threat detection with SIEM and XDR, which is known as Extended Detection and Response. SIEM and XDR is known as Modern Defense in SOC. This is our webinar agenda. Yeah, let's move on to these topics. First is executive opening. We're gonna learn about cyber threat landscape and why detection matters in this attack scenario. Second, we are going to learn about SOC foundations, which includes models, detection lifestyles, and those things. Followed by that, SIM architecture. It consists its components, use cases, and which platforms are SIM architecture uses like that. Followed by that, we are going to see about XDR architecture, capabilities of XDR uses in SOC. After that, combined SOC models, unifying SIM and XDR operations. Followed by that, detection use cases. We can see briefly about Metri attack mapping. Then advanced capabilities like SOAR, future of SOC, AI and ML in detection response. Let's move on to the section one, executive opening. First, cyber threat landscape. Usually, we know cyber threat landscape is a dynamic, AI-powered ecosystem characteristic by what you can say automated attacks, shifting focus towards the vulnerabilities. That's we known as a cyber threat landscape. In on that, first we are also ransomware. Usually, attackers target some organization and demands money, which we known as a ransomware. Phishing and identity attacks, credential theft like users login and passwords and MFA bypass like uh, accessing their two-way authentication and so on. So then insider threats, privileged access misuses. In an organizations, the employees also misusing the credentials for some money or something. Key risk in cyber threat landscape is exploitation of cloud infrastructure by state-aligned actors and APTs, cloud attack surfaces. Next, evolution of security operations. Previously, we SOC analysis used traditional SOC, manually log review. SOC analysis usually review the logs manually by one. From reactive manual log monitoring in 90s, automated ECA systems today. This is our journey moved through SIM-centric compliance. Yeah. Gen 2 SOC. Usually, most of the organizations of SOC uses Gen 2 SOC for past 5 years, like SIM adaptations, adapting to the SIM and concepts of compliance, basic rules, and 24 into 7 monitoring is the crucial main thing of monitoring. Gen 3 SOC. Actually, we are like small scale industries are using Gen 3 SOC. That includes threat intelligence feeds, reactive and manual threat engineering, EDR integration. Modern AI-powered cloud native SOAR, which is in next gen SOC platform that prioritize rapid automated detection and response. That's unifies us XDR and SIM, which is not SIM versus XDR, it is SIM and XDR. That's the main concept in next gen SOC, which combines both and work together to find vulnerabilities and logs everything. Next, section 2, we move into SOC foundations. What is Security Operations Center? As a SOC analysis, we know what is SOC. Continuous monitoring, 24 into 7 visibility across endpoints like systems, network, cloud, and email layers. We need to monitor 24 hours in a week. That's the main scope of SOC. Detection and triage. We need to identify genuine threats like threats can everywhere in a SOC point of view. So we need to identify genuine threats with an high alert volumes. There will be many alert. There is a high alert, low, prioritizing with their standards. So we need to identify genuinely. After that, investigations. Majorly, like L3, SOC L3 will investigate the deep dive analysis. After incident response, threat intelligence integrations. This is SOC. We move briefly into SOC. SOC analysis escalation model. Usually SOC L1, Tier 1, which monitors SIM dashboards, first pass alert qualification, apply baseline playbook. Usually L1, the role of L1 is to escalate to L2 SOC analysis. Usually L1 mainly focus on blocking simple tasks like monitoring the dashboards and blocking simple user IP addresses. If after like small responses, we need to escalate into L2. That's what here mentioned as Tier 2 incident investigator. SOC L2 investigates deep dively and validate Tier 1 escalations, their documents, what they found, what is the main source of their attack, evidences, produce incident reports. L2 SOC analysis escalates into tier 3 SOC L3s like threat hunters. They have the power to take actions of custom detection logics and threat interproductions. Detection engineering overview. Detection engineering. We know detection engineering is a proactive lifestyle which based process of researching, developing, and what you can say, tuning security detection rules to identify mainly malicious activity. That's the main scope. Detection engineering, discipline of building, testing, and maintain logic to identify the activity at scale. Detection rules, signature based and behavior rules, fire when known bad patterns appear. That's we know. The key aspects of detection engineering is continuous cycle. It is not a project but a continuous planning, like what you are going to implement, what you are going to testing, tuning, monitoring for improvement for further future. That's the continuous cycle. Behavior analytics establish baselines, alert on statistically deviations. Behavior analytics. If an alert comes from low priority, we can take it as easy. If it's medium means we have to check once. If high alert means we have to stay focused on deviations which can cause a huge damage to our systems, endpoints, anything. Threat informed strategy also used here. Programs use frameworks like Mitre attack to align detection coverage. That's what use case development says. Continuous validation. As we told before, red team, purple team exercise to verify coverages and close gaps. Like penetration team and both red and blue team will verify the coverage and close the gap which is bending by by investigation. There are many components in detection engineering also. Involves telemetry sourcing, detection, logic development, then mainly some rules, behavior, and reducing false positive also a main aspect in detection engineering. Yeah, this is threat detection lifestyle. This is what we learned from the beginning. First, collections, normalization, analysis, detection, investigation, response, improvement. This consists of roles like Tier 1, Tier 2, Tier 3, SOC analysis roles, collection of data, normalization, and analysis those data, and detect individually and investigate individually, deep dive investigation and response, take actions and improvement on a security role, on a security ensures of a organization. That's we known as threat detection life cycle. Then security telemetry, data sources for detection. Yeah, data sources for detection. Mainly it compromises logs, network traffic, endpoint data, and user activity. These are the data source for detection. Usually. It is crucial for identifying security threats. These are the main thing to identifying security like logs, network traffic, endpoint data, and user activity. First, endpoint telemetry process creation and injection, files system changes, registry modification, EDR, AV alerts, etc. Process monitoring, yeah, process creation and injection means tracks process creation, modification. Just to detect malicious code execution, we need to terminate that. That's the endpoint telemetry. Usually, next mainly it followed by network traffic. This is the main thing in data source of detection. Network traffic. We need to stay aligned on flow record like full packet capture, DNS query logs, proxy, gateway. These are the security telemetry. Key sources includes Windows registry, process execution, network traffic, like and all. Identity and authorization. Active directory events. Directory events should be in up-to-date active, multi-factor authentication success failure, privileged account activity. These are the identity and authorization, like we know we calling as auth. These are the data sources for detection. Cloud telemetry. Cloud service logs like DSOO25 and application logs, often mapped via like Mitra attack, cloud trail audit logs, IAM policy changes, storage access patterns. These are the main security telemetry. These are known as data sources for detection. Let's move on to section 3, SIM architecture, centralized log management, correlation, and analytics. What is SIM? The full form of SIM is Security Information and Event Management. SIM is a cybersecurity solution, usually, which provides real-time visibility, threat detection, incident response, everything. And usually it analyzes the log data from what you say from everywhere, like organizations, IT infrastructure, like that. Here it is categorized into two types: SIM, Security Information Management, and SEM, Security Event Management. It combines log management and event monitoring. This is categorizing here. Combines log management and event monitoring. This is the main scope here to identify security teams to respond the breaches faster. That's why it categorizes into two types: SIM and SIM. Usually it's recovers from breaches faster. That's why both are used. Like SIM, security information management, long-term log storage and retention. These are the features of information management: historical, forensic, and compliance, policy management, audit trail maintenance. It will be stored for to maintain some confidential data. Event management for real-time monitoring, alert generation, notification, threat visualization, dashboards, incident workflow management. It's not security information management and event management differently. It combines, it works on unified. Like information management, event management works together for a visibility and threat detection. That's why the core functions of SIM, like information and event management, is collect logs and data from various sources like networks, server, application, centralized platform, everything. And it core function mainly it focus on analysis, correlation and analysis, as we see uses AI and predefined rules. These are used for log analysis data and recognize pattern for helping to potential security threat. These are the detail about SIM. This is our architecture of SIM: log sources, collection layer, passing and normalization, correlation engine, alert generation, dashboards. These combines first three will act as a information management and next three will act as a event management. This is SIM architecture data flow. Now we are going stepping into main topic: log collection and normalization. This is the initial step in SIM architect. First, syslog investigation, like investigation, UDP and TCP syslog collector. Syslog contains UDP and TCP syslog collector, Kafka-based streaming pipeline, agent-based forwarding. These are the sources and mainly focus on syslog investigation, parsing and field extraction, group, leak formats, custom passes source, like that. And let's move on to correlation rules and analytics logic. Usually, correlation rules and analytics logs in SIM is used for combine low-level logs into action. This is the main role in combining these two. Usually, it's alert burst, like predefined criteria like timing, sequence, relationship. It's focused on timing, sequence, relationship on combining these. First, multiple fail log success. If a user is logged in multiple times but it failed continuously, means it generates a high alert. This is one of the rules we have set in by the admin or user. If continuous failed login means it will generate as a high alert. Next, impossible travel detection. Successful login from geographically impossible source IPs within short time window. Like if a attacker logins from India, means after 5 minutes that unusual login is from Russia, means it will known as a impossible travel detection. It is so critical So we need to take a immediate action about that. That's we call as time window. Like roles often require events to occur within a specific time frame, like file logins within 1 hour to detect immediate threat rather than random. Yeah. Then privilege escalation chain. Standard user, admin group add sensitive data access within 30 minutes. That's a critical alert. Privilege escalation chain. Then lateral movement pattern. Sequential authentication attempt across multiple internal hosts from single source, which is sequence and ordering. Crucial for behavioral detection. Yeah, like what do you say? Requiring successful login to follow a series failed attempts, which is known as lateral movement pattern. Let's let's move on to SIM detection methodology. Signature based detection. Usually first I'll tell what is SIM detection methodology. SIM detection methodology involves, collecting normalization as we see in data flow, normalizing and analyzing log data across any organizational infrastructure. Yeah, in SIM detection there are key techniques like matching fail logins. We are matching fail log. If before 1 hour there is five fail login means we need to combine that fail login. That's a one technique for behavioral analytics to identify the threat intelligence feeds. That's the main thing. First, we gonna see signature based detection. First, known IOC matching like IP, hash values, domain names, etc. Pattern rules against even key, fast, low, false positive, low, false positive, unknown threat. These are the signature based detection which we are using for every actions. Next, behavioral based detection. Baseline normal activity per user post alert on deviation from baseline, like rule based pattern matching. Mainly the foundation of SIM. These detect like threads based on predefined conditions, like the rules we have predefined conditions. If we add more than 5 logins followed by successful one means it based comes under behavioral based detection. Then anomaly based detection, static modeling of event frequency, ML driven, like machine learning driven, effective for insider threat and data exfiltration. Next, UEBA, which is known as behavior analytics, is usually establish a baseline for a user and entity or organization. It automatically identifies the unusual behavior. That's why it called as behavior analysis, UEBA, like a risk code, user profile, like that. Example, if user accessing unusual server means it abnormal data will transfer. That is called as behavior analysis. Okay, let's move on to primary SIM detection use cases. Usually, primary SIM detection means identifying, correlating, alerting on suspicious activity is known as primary SIM detection. Yeah, these environments are used for main purpose is to reduce the risk. That's why primary SIM detections are used. We'll move on to the core use cases. First, majorly it causes of brute force and password spray, like high volume auth failure patterns. Brute force means we know they are trying different passwords to access the user's login and password. Distributed spraying across accounts, account lockout chain analysis. This is called a brute force. Usually, it includes detecting a brute force login attempt means identifying the malware command and control communication, detecting threat, insider threat, etc. These are the main cases. Then insider misuse detection. After hours access to sensitive data. Bulk download before registration. Role access not matching job function. When attacker tries after hours accessing sensitive data, spends more time on accessing sensitive data, downloading huge files from KB to GB before resignation. That's called as insider misuse detection, which attacker acts inside an organization or any environment. Next, enterprise SIM platforms landscape. We are going to see platforms which SIM uses. Most of the companies uses Splunk Enterprise, which is the licensed one commercial used for many startup companies use Splunk. Key strength is a search power ecosystem flexibility. The use cases of Splunk will be more efficient, like not critical to use or anything. Industry leader, high listening cost. SPL query language. High listening cost means usually Splunk will requires high listening cost because it is a one of trusted enterprise security which is used by many organizations. Microsoft Sentinel. Microsoft Sentinel is an Gen 3 SOC like which focus more on cloud data like Azure, AI Copilot, which is a more advanced which unifies combines with SIM and SOC, scales with Azure, which is more advanced than Splunk Enterprise. Most of the startup companies and small scale industries uses Splunk. Microsoft Sentinel, it requires a huge database like Amazon, like Azure, like that. Third platform you're going to see is IBM QRadar. It is a commercial which can be used by any cyber companies. Mature correlation engine compliance. It consists of more predefined rules, which is known as compliance. The enterprise grade, government sectors and presence. Wazoo. For anyone we are learning for a SOC, Wazoo is one of the best open source tool, which is free, extensible, and user friendly. Also, it is a great for anyone starting a new enterprise. It is a growing community. We can learn, we can use everywhere, which includes totally various kinds of components. So we are just one of the best open source tool of SIM platform. In SIM operational challenges, these are the one of the challenges will may face by any SIM users. Alert fatigue. SOC analysis overwhelmed by high alert volumes. Too many high alert volumes will cause us a alert fatigue, which is known as which alerts is a more critical, which is a serious issue, which is a serious alert, which will be cast fatigue that we known as fatigue. Too many alert means the SOC analysis will don't know which alert to be responded. Critical signals buried in noise. Yeah, that's what I said. If 100 I alert comes means we don't know which is critical alerts. We have to manually check the I alert. That's what I here mentioned here. Analysis, burnout, and detection misses. In 100 alert, one critical alert may miss. That's what alert fatigue mentions here. False positive rate. Poorly tuned rules fire on being activity. Wasted investigation cycles like erosion trust in the platform. False positive rates. Not every alert is make us damage in our. It will consume our time also. That's what false positive rate indicates. Rule tuning complexity. Rules degrade as a environment changes. No feedback loop. Requires dedicated detection engineering time. Let's move on to log volume and cost. Cloud and container elementary scaling, storage and licensing, testing latency under peak load. Log volume and cost. It will also cost our team and time. It contains a more sustainable energy, enabling faster thread redemption compared to like isolated security tools. That's what I mentioned here. Next, section 4, XDR architecture, extended detection and response architecture. What is XDR? Extended detection response. Yeah, here a modern cybersecurity approach like Unify means combines security data from multiple sources. Yeah, multiple sources means endpoint, network, server, and cloud overload into a single platform, which is known as XDR, extended detection and response. Fine. Usually, XDR expands the detection speed and accuracy. Apart from SIM, XDR enhances detection speed and accuracy using AI and ML. XDR uses AI and ML to enable a faster threat detection. It includes cloud, identity network, email, which is known as XDR platform. There are many key usage like unified threat visibility. Unified means A&ML and XDR unified threat visibility. Collect data from endpoint, cloud, email, networks, more and more. Mainly followed by that, it will be focused on automated response. Automatically mitigate threat. It will give a mitigations to threats by restricting the network access, then shutting down the endpoints and reducing manual helps like that. These are known as XDR. Why XDR emerged? The problem security tools in silos. XDR emerged as a necessary evolution of cybersecurity. This is the main reason. Like in response to increasing of cyber attack, the security tools and critical shortage of skilled security personnel. That is the solving the silos problem. The XDR emerged. Fragmented visibility, EDR, email gateway, each in separate console. Analysis manually correlate data across tools, right? Alert overload without context. Previously mentioned as many alert will cause damage to find a critical alert. Tool fire in isolation, no cross, slow investigation. Mainly, this is the main problem to the case will go critical. Slow investigation. If manual analysis mean it usually take 3 to 7 hours. That's why it's converting into slow investigation, inconsistent response, mainly failure of security solution. That's what I said. Like previously, security team used tools like EDR for particular endpoints and networks that did not communicate well, but leaving a security blind spots. That's why XDR emerged. This is XDR architecture, unified detection pipeline. That means combined detection pipeline, multi-domain telemetry, centralized data lake, cross-domain correlation, AML analytics, unified investigation, automated response, more and more. These are the architecture of XDR. Core XDR capability. XDR mainly combine a security data from multiple vendor like endpoint, network, cloud, email into single what is it? Single console to detect and mitigate threat faster than other tools. That's the core capability of XDR. Cross-domain correlation like stitches email, endpoint, identity network, single instant timeline view eliminates a manual pivot analysis. Like it collects logs and alert from various sources like EDR, NDR, cloud or cloud, SaaS application, mainly SaaS application. Then automated investigation, AI-driven root cause analysis. Mainly XDR contains AI and ML. That's the main core capability of XDR is AI and ML. Attack story generation and minute. Automated investigations are more capable of XDR. Threat prioritization. Risk score instant queue, ML based. Like this contains assess discovery. Mainly the finding data, unmanaged device or network like that. Response automation. One click endpoint automation, automated account suspension. Unlike endpoint detection EDR, it provides a oversight like across infrastructure detection thread in network that we known as response automation. This is the core XDR capabilities. This is XDR attack chain, like phishing to compromise. Phishing email detected, malicious link like credential harvested. These are the steps like attack chain. Once a phishing email is detected, then malicious link is clicked. The user credential is harvested by the attackers. Suspicious login, like from any IPs, any new IPs, suspicious login, unusual login takes place, and organization endpoint data compromises later movement. That's the extended detection response attack chain correlation takes place. This is XDR platform followed by SIM platform. This is XDR platforms. Microsoft Defender XDR. Coverage domain, endpoint, identity, email, cloud, apps, networks. It covers every domain. So Microsoft Defender is one of the best XDR platforms. It covers everything now. Endpoint, cloud, more and more. CrowdStrike. CrowdStrike is mostly used for covering domains like endpoints. CrowdStrike Falcon is more oftenly used for endpoint leading threat correlation. Palo Alto is an independent platform. It is enterprise by Palo Alto Industries. It covers endpoint, network, cloud, everything. It also consists A and ML like SOAR technologies also. Sentinel one is more often like Palo Alto. Let's move to measurable benefits of XDR adoption. Mainly, the benefits of XDR is MTTD, which is known as reduced time to detect. Here, XDR can reduce incident response time by 50% itself, and decreases threat also by 65%, and it accelerates the investigation. So it will be very useful for creating timeline to attack a chain. That's why MTD is used. And here, main benefit is improved analysis, reduced alert noise also. It uses AI. It uses AI. Why? Because it relate alert into single incident, which reduces the alert of volume of alert requiring manual need. So it uses AI. So it is used by improved analysis productivity. That's we known as for faster containment. Automated in one click, and action reduces by MTR by 60 to 80 percentage. Then these three comes under lower cost of ownership, which is known as TCO, by consolidating COL tools like EDR, NDR, SIM into single platform or organization or anything, which is using 40% saving in security from manual. That's why these three comes under TCO. Note that lower total cost of ownership, which is known as TCO. Then this is the comparative analysis. This comparative analysis of SIM, this is XDR. Primary purpose of SIM and XDR is log management, compliance, and correlation. Main SOC team will use a SIM tools. This is the most important for SOC. Log management, compliance, correlation. XDR is threat detection, investigation, and response. As I told earlier, it is not SIM versus XDR. It is known as SIM and XDR, which combines and unifies both and works together to act better. That is the primary purpose. A data scope, mainly broad log investigation from all sources, deep telemetry from security controls, which uses AI also. Analytic is a rule-based and statistical, which is this we are mentioned before. This is the rule-based. We have set up predefined rules and statistical. This is known as SIM. XDR is a AI and ML across any domain behavior, which uses AI and ML also. Response capability. Mainly SIM generates alert and workflow only, but XDR native automated response action. It will take a certain actions like simple actions for blocking a particular IP or taking temporary actions, which is known as XDR response capability. Investigation analysis driven pivot analysis, which is a manually done by the SOC analyst. Like we need to check the single alert by individual. XDR is AI assisted automated case building. XDR has some predefined access to take action on particular alert, like blocking IP, compromising that user. That's called be known as AI assisted. A deployment model, cloud, hybrid, or on-prem primaries. XDR is more often is a cloud native. Best for SIM is compliance, forensic broad visibility. XDR is threat detection and SOC efficiency. These are the comparative analysis of SIM and XDR. Section 5 is SIM plus XDR operation model. Why SIM and XDR work better? Yeah, as I told earlier, it is not SIM versus XDR. It's SIM plus XDR. This is the main concept in SOC. SIM and XDR needs to work better together. It's not versus. SIM provides centralized log, as we see earlier. SIM provides centralized logs, broad source investigation, historical forensics, custom correlation rules. As like that, XDR provides deep cross-domain correlation, automated response actions, AI incident, rapid investigation, native security, like that. These are the integrated detection architecture. Like integrated means combining SIM and XDR. All log source. Yeah, first three is a SIM, next three is a XDR. This is the integrated detection. All log sources, SIM investigation, threat intelligence, peer correlation, UIQ, SOC response. SOC workflow. This is a workflow of a SOC. When alert generated, autocorrelation occurs. Analysis triage individually by L1, L2, and L3 categorized by triage. And investigation and enrichment. One set of TIA will escalate their actions into investigation enrichment. Investigation enrichment escalates to response execution and post-incident review. This is the workflow of SOC. This is incident scenario. suspicious authorization threat contained. Anomaly detected first step, then XDR enrichment, risks were elevated, endpoint isolated, threat contained. This operational benefits which you saw earlier also, SIM plus XDR combined. Next, we move into real world detection use cases. This is impossible travel detection. As we mentioned earlier, impossible travel detection is a security mechanism actually. Flag user account accessing system from, as we mentioned earlier, geographically distant location within unrealistic short time in frame. Before 5 minutes, takes place in Mumbai. An unusual login attempt takes place after 2-3 minutes from Russia means this is called impossible travel detection. I can explain it is in with example also. As we told you, use a log from New York at 2 p.m. right? Okay, it's takes place in 2 p.m. Again, an unusual logs from Tokyo at 2:30 means it is physically impossible, right? That's why known as impossible travel detection. This method is called as SIM2 login logs, which calculates the distance between a IP geolocation point and it divide the escalated required travel speed, which is known as impossible travel detection. This is another use case, brute force and password spray detection. Brute force and password spray detection means it mainly identifies the automated, like malicious login attempts, which uh, which compromises credentials also, which is known as password spray detection. First, brute force indicators, password spray pattern detection and response team. The main use cases is to identify unauthorized access attempt, where example a single password is tested against high volume within a short time. That is known as a detecting password spray detection method. Let's move on to privilege escalation detection. As we see it before, service account activity outside normal business hours, like technology stack that enable identify, predict, and respond to threat. Ransomware behavioral detection. These are the phases of behavioral detection. Phase one, initial access, execution persistent, and defense evasion, and encryption behaves like that. These are the alert triage methodology from alert to action. This is the main alert triage. Validate the alert, classify the threat type into high, medium, critical threat type. Prioritize by risk, as I told. If it is an high risk, act accordingly. That is the main thing. Then advanced SOC capabilities. AI and ML. These are the foundational to maintain the threat detection, like modern threat detection. It provide a real-time automated analysis of a massive data volume to identify. That's why AI, ML, and modern threat users to key to predict and respond to threat. First, ML anomaly detection. It is a normal behavior of user or device or anything. It flags the potential breach. That's why ML anomaly detection used as a key here. AI-assisted triage. AI-assisted triage means some set of problems can be assisted by AI itself, like blocking IP, stopping an endpoint IP, like that. Then predictive analysis, like ML model analysis, email traffic, or phishing malicious intent in real time. That is known as a predictive analytics. Then security in Copilot and Gen AI. It is in one of them automated and AI-generated investigation for leadership. Next, SAW. This is the final topic. This is an important topic also. SAW is a security orchestration, automation, and response. It transforms manual SOC tasks into automated. This is the most advanced SOC architecture. You can say like that also. Mainly, it enables security team to integrate, like it integrate the security tool like automate routine, repetitive tasks like that. It can be integrated separately for a security team. First, brute force attack detector, auto block source IP on firewall. Yeah, AI assisted. That's what I say previously. It can have access to block some IP source. That's what it says. Malware detected on endpoint. If a malware detected on endpoint, auto isolate host from network. It will isolate the endpoint separately from the network. These are the one of the other suspicious account activity. Disable AD account. Notify user manager and everything. Phishing email reported. extract IOC, delete similar emails, block sender domain. That's why SAR is used as one of the advanced task into automated playbook. These are the key challenges which takes place in detection engineering: false positive volume, coverage gap, adversary evolution, skills shortages, more on that. Future of modern SOC. The future of modern SOC, mainly it is rapidly evolving from manual monitoring into proactive. The manual monitoring is engaging into AI-driven, highly automated models that we usually calling as future of modern SOC. The main shape of the future SOC is AI-driven, rise of AI-driven operations, autonomous SOC, AI-driven detection engineering, continuous threat hunting, and adaptation of EDR, XDR, and unified platforms like combining SIM, SOAR, XDR platforms. This is known as the future of modern SOC. If SIM, SOAR, XDR platforms can combine together, it will converge towards security platforms, all-in-one security platforms. So it will be used as a detection tightly, so it can triage, investigate, and help to combine alert. That is the main scope of future of modern SOC. Yeah, Section 8 executive closing. These are the key takeaways. Please note on it. Any if you guys have any questions, please let me know in the comment box. This is our company's learning page, learn.bcbuzz.io. You can check various free videos. You can access free also. This is our WhatsApp channel, BCBUZZ WhatsApp channel. Please join. If you have any queries, please let us know. Thank you.